Hi, just wanted to showcase some little progress with this. It's now working in a localized fashion to where the rollers spin as a box slides over them, and works fairly well. You actually can reverse direction on that, and the box is just cycling through a makeshift teleporter kind of deal. Literally just moving the box back after it falls into it. But you can see that the rollers actually roll. And this is implemented by, see, that one didn't move that time around. It's implemented by some sort of a pool, if you will. So the more roller you have in the sequence, the more accurate the process is. And I have a bunch of stuff open anyway, but performance is, 120 FPS right now, so depending on how many boxes you add, it'll probably be more or less. So let's do that. Let's add a few boxes. Put one there, put one here, put one here, put one here. The boxes might start bashing into each other, but okay, so now you can see the rollers are still running. We're still at 120 with, I don't know how many boxes that is. To put more in, at this point I would have to, put more stuff. But let's go over how that's made, right? So it's fairly simple. The box itself here handles the movement and everything in it. So as always, we look at the component overlap. If it overlaps, we start checking on tick. And what we do on tick is on tick. So obviously it's expensive, but since it is core gameplay and since we do need to move the object, I figure it's a good way to go about it. So we're doing a couple of things here. Let's go over this first. So this is the movement of the box, and I have it in a separate sequence. In which we're just literally setting the actor location. In fact, let me remove that stopwatch. So we're just taking the actor location, we're adding the forward vector of the object that we are interacting with, scaled by a value so that it's a little faster, than just the vector. And we're setting that as the location without sweep enabled. That's important because if you enable sweep, then you start colliding. And in my case, the rollers each have their own sphere or, capture collision. That does tend to get stuck. Then we have this here. We're just doing some basic math to check the direction that we're traveling. And we'll get to where that goes in a minute. So here we have, like before, we have the check for the overlap with the box size. We're checking to see what instances, and then we run into the implementation of the object pool to determine if we need to fire or not. So this is a map. If you're not familiar with maps, it's basically two values into one. You use one as the index, and the other value is the value for that index when you use a find. There are a few limitations to maps, namely, to be able to change a value, you have to remove it and add it. And then if you remove the value and you try and get the value here from the value that you removed, you'll get a 0. So you need to memorize the value beforehand. And that's what's going on over here. So each loop, we set the index because that's easier to move the variable around rather than having all the wires. We find the value here. And if it was found, so if we had it in the pool, we do something. And if it was not, we do something else, which also adds the value to the pool with a 0 index. So then what does this do? Well, this checks that the mesh you interacted with is valid, just because if it's not, then let's not spawn any actors. And then we spawn a special actor. This actor is called Roller Helper, And you might guess by the name, it helps the roller roll, because the roller is inside the instance, and you don't really have a way to interact with all of them at the same time when you do this. So spawning an additional actor, Clockwork Orange's suggestion, is just great. It just works, and it automatically deletes and recycles, so it's kind of perfect for small scale like this. So what we're doing is we're just getting the instance transform, and we're placing the actor on that instance transform. Just for clarity, in case you're debugging, you have it where the roller is. You don't really need to do that. And then off of this spawned actor, we set the variables for the roll, and that's where that direction value was getting tossed at earlier. So that's pretty much the code walkthrough for that. Now the object pool right there, right? So when the object is already in the pool, we do a basic check to see how much time has elapsed, and if the time has elapsed is less than 0.1 seconds, then we update the time of that instance to whatever the time here is. And this 0.1 is completely arbitrary, because the actual length of the animation for the roller is about 5 seconds. It's about 0.5 seconds. So if the value is above that, we remove the item from the pool. This allows it to create another instance. And basically, the faster the box moves, the lower this number's got to be for all of the rollers to cycle. What do we got here? So that's the box. And that's pretty much all the movement. Let's take a look real quick at the... no, the teleporter is just too silly. It's inside the conveyor belts, right? The roller helper. Okay. So what does the roller helper do? Well, it checks that the values are there, or it sets the values rather. It doesn't even check them, which it probably should before trying to apply stuff to it. In fact, let's do that. Drag the roller here. Is valid there, and inject that over here. And when it's not valid, we're going to destroy self, so just drag it into this box, just like that. It's fine. Compile, save. So what do we have here? We memorize the values, we save up the initial rotation, and I'm only doing this at the initial rotation because of the engine's limitations with rotations and gimbal lock. So anytime you try and read and update this value, you'll hit gimbal lock eventually to where it resets. And for instant static transforms, it was resetting for me. It was getting stuck at -90. I have no idea why. So I went around that. We saved the value at the beginning. We check the direction, and in my case, it needs to be greater than 0 to activate the correct. And then we run the timeline. The timeline goes from 0 to 360. So it's one complete loop, which looks like more when you're actually looking at it, but it's really just one loop. And on update, we are getting the instance transform minus the Y. We are adding the rotation to the initial rotation. So this is over time 0 to 360, getting added to whatever the value was. It's probably 0, by the way, initially. And it's updating the transform, which let's remove that lookup node. Okay. So it's doing this in world space. I'm not sure. I'm not even sure that matters, to be honest. But it's important to go mention that if in case it doesn't work. And on finish, it destroys itself. And the destroying itself part, that's kind of important, because if you don't, you'll end up with billions of actors on screen. and that will cripple performance. But it's also important to note that the roller is happening on its own timeline and not on tick, which is a little more performant than it would be if you were doing this on tick. Then what else? The conveyor belt holds absolutely no other code, so this was just the creation from last time, and that's it. That's all there is to it. The event graph's completely empty. In fact, let's just even do that. So the functions aren't available when I look at it, on the left panel. That's it. Roll, roll, roll. You really can't tell which direction they're rolling either, as much as you try. Anyway, good luck.